Having seen the first law, let us discuss Maxwell's second law in this equation. It's a rather brief equation. If you recall, your Maxwell's first law was based on Gauss law for an electrical field. Now, going on the same lines, your Maxwell's second law is going to be based on Gauss law for magnetic field. Okay. So now let us say, so we shall be dealing with Maxwell's second law, right? We shall be dealing with my Maxwell's second law. And this starts with Gauss law for a magnetic field. So Gauss law for my magnetic field states that the flux through, total flux through a closed surface is equal to 0. We have all seen what flux line is. A magnetic field creates a magnetic induction. And this magnetic induction is determined by the number of flux lines per unit area, the number of flux lines. Magnetic induction sends a magnetic flux. So you will have magnetic induction is equal to total flux per unit area. So that is what is flux is. And the flux over a closed surface is 0 is Maxwell's second law. So now, in terms of magnetic induction, now you can write over a surface, let us say, the magnetic induction, B dot ds is given by the flux. If you say ds is the area, then you know phi is equal to B dot a, where a is replaced by the area ds. So this over a surface integral B dot ds is equal to phi is what we have. Now comparing these two equations, what can I write? I can now write the surface integral B dot ds, that is over a surface, is equal to 0. So this is Maxwell's second equation in integral form. So to convert into differential form, again we are invoking Gauss divergence theorem. So from Gauss divergence theorem, I am not going into it again as we have already seen it. We can write this surface integral of B dot ds is equal to volume integral of divergence of B over a volume. So which means I can replace this with this in this equation. So what can I write now? I can now write volume integral of divergence of B, the magnetic field, is equal to over a volume is equal to 0, or I could write del dot B, divergence of B is equal to 0. This is Maxwell's second equation in differential form. Okay. So we have seen Maxwell's first equation. We started from Gauss law for electric field. We have seen Maxwell's second equation, which started from Gauss law of magnetic field. In the next lecture, we'll see Maxwell's third equation.